Okay, so I wanted to introduce my triangle project. I guess some people could call it a competition, but nonetheless, it's really fun. It's probably my favorite project, certainly in seventh grade, maybe even in the middle school, although the Pringles project is really fun too. But anyway, I wanted to chat with you about it, just kind of introduce you to it and show you what we kind of try and accomplish with it and it's been great. We're on day number 2. Today was another day of testing, figuring out what the noodles can and cannot do, what the gumdrops can and cannot do, and it's just to see the excitement and the energy is phenomenal. So anyway, here's basically how it works. The students in the competition are given one box of noodles and 30 gumdrops and a platform. So the platform is a 1x1 dry erase board, and the structure has to fit on the platform. That's how they submit their project, their structure for judging, so to speak. So they get 30 gumdrops, box of noodles, and a platform. For testing, I give them unlimited noodles, unlimited gumdrops, and they just kind of test and they don't go over 30 noodles or over 30 gumdrops certainly, but during testing. But I want them to kind of test and fail and test and fail and test succeed, test fail, test succeed, and see what does and does not work. And we do it over 2 days because they think about it after the first day of testing. They think about it. Oh, I could try this and I could try that. So they come in with all these cool ideas and cool drawings and designs, and they want to try it. So that's why we do 2 days of testing and not just one. Because the first day of testing, they kind of figure things out, learn a little bit about what the noodles can do and what they can't do, and then all of a sudden towards the end they start, oh, we could try this, try that. And so I give them that second day to really try and implement that. So in fact, some ask if they could come in during a study hall on the second day of testing. That was today, and so that's what they're going to do. It's pretty cool. So basically the rules are kind of like I laid out before. Each team will build a structure using a maximum of 30 gumdrops, and each team will use a box of noodles. So there you can kind of see what the gumdrops and noodles look like. The noodles are just under 10 inches long. They're just your basic generic straight spaghetti noodles, and then you can see in the bottom picture there the gumdrops are just over a half-inch long and wide, and they're kind of gooey and they're kind of yucky, but they're covered in sugar and the kids love it. But they're touched by all these hands, and so the temptation to eat them is quickly gone. So things we talk about, and we talk about this in class, is how the structure will be judged. It's judged by how much weight it can hold and how high it is. For example, the structure that holds the most weight, and I use these big, thick, huge washers. They're about the size of a silver dollar, and I've got a few hundred of those, but I end up having to use rocks as well because the structures are so well designed that the washers are a no-brainer. And so they're ranked. They're ranked if they're the strongest structure. In other words, after all is said and done, all the testing is done, all the competition is over, and you're ranked as the strongest, you have a score of 1. If you're the tallest structure, you have a rank of 1. And then the rankings then go down from there. So, for example, if your structure holds the least amount of weight, you're ranked. In this case, it'll be 10. And so the lowest combined score, it's like golf, the lowest combined score wins. So obviously the best score you can get is 2. First for height, first for weight. I've never had that. Usually it's second and fourth, or second and third, or third and third even, I've never had the tallest structure be the strongest. And of course that leads to a pretty cool discussion as well. The winner gets a root beer float and a giant candy bar. Second place gets a huge candy bar, and third place gets candy bar. And so all the students receive a juice box, and we have a party on the last day, and just sort of, it's fun and students remember first, and they remember the experience, and we kind of debrief the whole competition. We debrief what we learned, and it's pretty awesome. It's pretty awesome. And as I tell them, once this competition is over, or even during the competition, they'll never look at a bridge the same. They'll never look at a building the same. They'll never look at the ceiling in the gym the same. They just see triangles everywhere, and the power of triangles and the strength that a combination of triangles can have is awesome. And they never see it the same. Even my 8th graders, to this very day, we still talk about it. It's pretty fun. So the process. We brainstorm ideas. Make it very, very clear on day one that all ideas are valid. The reason I say that is some students, this is right in their wheelhouse. They love to build. They build at home. They just love it. But maybe their partner is just sort of getting into this, and maybe it's not their most favorite thing in the whole wide world. There's still value in both ideas. There's value in both teammates. And to see that kind of teamwork happen and all that good stuff is really cool, and the validity of each person's ideas. So then we talk about hypotheses and what a hypothesis is, how to test for it. They kind of draw their hypothesis to some degree, and then they actually build it and test it. That's pretty fun. They hypothesize over what the difference is between one noodle or two noodles next to each other. And so they kind of test that, and they put washers on it and test the tensile strength and the compression strength and stuff like that. And then at the very end, they submit their final structure. So again, a hypothesis, a proposed explanation for an observable phenomenon. So it must be tested, must be able to be tested. So they have their idea, they throw it out there to their teammate, and then they test it and see what happens. Brainstorm. Brainstorming is huge. That even is kind of an ongoing thing. That's, like I said, the students, they try it on the first day, and then later on, even at the end of that first day, they start thinking, oh, what about this? And they start talking and bouncing ideas off each other, and they really start to work well together. And they learn that, man, my teammate, they really kind of know what they're doing. And the other teammate says, yeah, I didn't think they knew what they were doing, but they do. And so they start to really validate each other's ideas and brainstorming thoughts. So we talk about this. I show them this piece, and we take a noodle and we hand test a noodle. Just every student gets one noodle, and they kind of see what its properties are. Its bending, its tensile strength, the compression. And we talk about if you see that the first picture where the forces moving down on that noodle, the forces coming down on that thing, they see, wow, it's pretty strong. And then they start to realize when I grab farther up the noodle, in other words, I shorten it, how much more powerful it is and strong it is. What they also notice is as soon as just the slightest bit of force starts to leave the noodle, they realize that it snaps with hardly any effort at all. As long as that noodle stays vertical, or it stays straight, and the forces are transferring right through the noodle, how strong it is. But again, as soon as they see it kind of bend a little bit, boom, it snaps with just even the slightest bit of forces on it. So again, this is the testing. So these are some pictures of the testing and trial and error. So this is day one, and you'll see that in that bottom picture, the girl in the red, she drew a design on the table to sort of think, well, what about this idea? So that's part of the brainstorming process. They work together, like in the upper right-hand corner. They're working kind of separate. They're testing their own theories. The group in the upper left, in the blue there, those two are kind of working together and actually building one structure. And then the girls in the bottom right, they've got the triangles there. They're thinking, what does this look like? How does it work? And all that good stuff. So there's different ways of testing. They can draw, work together, work individually. And I always say to them, draw, 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 draw. So a lot of them have camera phones, and so they take pictures. A lot of them, have an iPod Touch that has a camera on it, and they take a lot of pictures of their tests. It's pretty cool. Okay, so again, this is kind of a repeat. But I show them these pictures of a truss bridge and what that looks like. And then we have about 3 days of building. Sometimes we spill into the 4th day, and then we have 2 days of competition. And then I show them these, and we talk about scaffolding. And then I show them kind of a wide-angle view of the Pont de Quebec, or the Quebec Bridge, and we look at all the triangles, and they inevitably they'll say they just saw it as a bridge. But as soon as we start even talking about triangles, they see them everywhere. They see them in the structure. They certainly see them in that bridge. And then it's awesome. So anyway, that's kind of how this thing works. It's so much fun. The learning is unbelievable. There's a lot of laughter and silliness, and especially at the end when the competition happens, because we go till failure. So as soon as the structure fails, that's when it's over. So the judging, let me just give you a sense on what the judging looks like. I put a 1x1 platform on top of their structure. I measure it to the table in centimeters. It's recorded in an Excel spreadsheet, a Google Doc, so all the students can see everybody's scores. And we measure it, and we record it, and then we start to lay weights on it. We lay weights on it, and we put washers and washers and washers. And rarely, if ever, do I have a group that cannot hold all 250 washers. Their structures are so sound that they can easily hold that, and I start piling rocks on it. As soon as the structure fails, and my judgment is the final judgment, and basically what I say is, if this was a real structure and I would be unwilling to stand on it in the real world, then it's no longer viable, and then the structure is over. And so then we write down how many rocks and how many washers and rocks are on there, and that's the recording. So again, it's height and weight, and that is the final decision, and I'm telling you, it is so much fun. So anyway, I hope that explains a little bit about our triangle project, triangle competition if you want to call it, for 7th grade.